Happy day. Today we are learning about the distributive property, which is a little bit of pre-algebra, so I'm very excited about this. All right, let's get started. The distributive property. The distributive property allows us to multiply each term within the parentheses by the number outside the parentheses. So let's say, we'll just say inside. That's probably easier. So, well, let me get my pen going here. Hold, please. All right, here we go. Inside. Ooh, that's a really bad D. Inside, parentheses by the number outside. Sorry, my Apple Pencil is broken again, so it looks like my finger's going to work today. Algebraically, we could say, so this is a little tricky. So we're taking the A times the things on the inside. So A times B plus C could also written A times B plus A times C. If you don't get this yet, I'm going to show you many examples so you'll understand it. And then this next one, A times B minus C, could also written A times B minus A times C. And again, we'll go over this. So right now, we're just kind of writing in our notes. Be careful with your signs when you're multiplying by your integers. We still have some struggles with multiplying by integers, so that's something we're going to continue to practice kind of as we move through these units. All right, let's do a bunch of examples so you have a good understanding of this. All right, I like this problem. Each of the 4 members of the Robinson family ordered a drink, 2 slices of pizza, and an ice cream cone. Now notice, even though there's 2 slices of pizza, we're just using one variable P, okay? So I don't want that to be confusing. So the 2 pizzas together are gonna be one variable. So distribute and write an expression to represent their order. Okay, so each person, so there's 4 people. So what I would think is there's 4 drinks, 4 sodas, plus there's 4 sets of pizza, we'll say it that way, right? 2 slices of pizza, plus 4 ice cream cones. So notice we did 4 times this guy, 4 times these, and then 4 times ice cream. So we are distributing that 4 across the parentheses. Okay, we're taking that 4 and we're multiplying it times the soda, and then we're going to go and multiply it times the pizza, and then we're going to go and we're going to multiply it by the ice cream cone. Okay, and then your expression would be this guy down here. We had 4 drinks, 4 sets of pizza, and then 4 ice cream cones. And again, we're going to do some more thinking on this one. All right. Now, my favorite way to do it is using an area model. And so just a refresher on what an area model is, if I was going to do 15 times 13, for instance, what I would do to do this multiplication is I would split the 10 and the 5 up, and the 10 and the 3, because that's 15 and 13. And then I would draw a little box. Anytime there's a plus sign, I would draw my little lines. And then this is an area model, because we're figuring out basically the area of these little squares. So 10 times 10 would be 100. 5 times 10 would be 50. 10 times 3 would be 30. And then 5 times 3 would be 15. And then to figure out our solution, we would add all that together. So that's an example of an area model, or we're going to use that area model to distribute or use the distributive property on these expressions. So let me get rid of that guy. We don't need him anymore. So we're going to do the same thing. So I'm going to do 3x plus 2 on the top. And I'm going to do 5 on the side. So you'll notice I don't have 4 boxes, I just have 2 to deal with. And then what I'm going to do, I'm going to start with the easy one. 5 times 2 is 10, so that's easy. And then 5 times 3x. So what we need to do is we multiply the 5 by the coefficient, which is just this fancy term for this little guy here. So 5 times 3 is 15, and then x is going to be like that. It's kind of like the drink and the ice cream and the problem. We have, we're taking that 5 times that whole term. Remember this 3x. Where's my little pointer thing? Can I find my pointer thing? This little 3x is a whole term, so think of it like an ice cream cone, or think of it like a drink. So don't think of these as individual things. This is one big thing. Or if it was a model, remember 3x would represent something like this. And so if we had 5 groups of these, let's say we had, that's one group. If we had 5 group of those, it would be 15 of those, right? 15x. So what we could say is we multiplied 5 times 3x plus 5 times 2. This would be expanded form. And then what we got for our final answer would be 15x plus 10. So this is what we're looking for. We have now used the distributive property to simplify our original expression. All right, let's do one more and then I'll give you a bunch that you can practice. All right, so we got 7 times x minus 9. Again, I would use an area model. So I'm going to put x minus 9 on top, and I'm going to put 7 on the left. You could do it either way. I just traditionally put the expression on the top. Anytime there's a sign is where I put my x, or my line, excuse me. And then I'm just going to multiply. 7 times 9 is 63. And then 7 groups of x, so 7 times x is going to be 7x. So if I wrote it in expanded form, I did 7 times x, I distributed it, and then I did 7 times 9. So I'm going to do minus 7 times 9. And then that gave us our answer of 7x minus 63. Pay attention. Notice I just kept this sign. So I kept it all the way throughout. Okay? We distributed that 7. And when I say distributed, another way to think of it is I'm taking that 7 and I'm multiplying it times x, and then I'm taking that 7 and I'm multiplying it times 9. All right. I think we got 2 good examples. Why don't you try one and see how you do? All right, so practice distributing by writing the expression in expanded form and simplest form. So try this one, 2 times x plus 6. Again, I'm still going to use the area model almost every single time until I get the hang of it. Then once you get to the hang of it, if you can do it mentally, that's perfectly fine. But area model for sure starting out. All right, pause the video, try this one, and then come back. All right, so I'm going to do my little area model over here. So I'm going to put 2 on the side. I'm going to do x plus 6 on the top. Draw my little rectangle. Anytime there's a plus sign or subtraction sign, I'm going to draw a line. 2 times 6 is 12. 2 times x is 2x. So expanded form, I did 2 times x plus 2 times 6. And then simplest form, I got 2x plus 12. Okay, let's try another one. Next one, 7 times 5 plus p. All right, so don't let the order confuse you. Okay, they mixed up the variable and the number, but nothing different here. Just use the area model and go straight through it. All right, you try it, pause the video, and then I'll come back and show you how to do it. All right, here we go. So I'm going to put 7 on the side. 5 plus p. I'm going to draw my little rectangle. Wherever there's an addition sign or subtraction sign, I'm going to put a line. 7 times 5 is 35. And 7 groups of p is 7p. So again, expanded form, I did 7 times 5 plus 7 times p. And then for my final answer, I got 35 plus 7p. Okay, notice this sign right here, I'm just getting from my original thing. Okay, so it just kind of follows me throughout. Plus, plus, plus. All right, let's try another one. All right, again, they kind of mix up the order here, but we don't care. As long as we have a good system, it works out. So I'm going to put 8 on the left. I'm going to draw my little box. I'm going to put 7 minus g. Notice that we have a subtraction sign, no big deal. Just going to draw my line wherever I have a sign. And then I'm going to multiply 8 times 7. Ooh, what is that? 56, I think. Double check me. And then 8 groups of g. So I'm going to do 8g. So my expanded form, I did 8 times 7 minus this time 8 times g. And then my final answer would be 56 minus 8g. So that would be my expression in the simplest form. Can't solve it yet, but once we get to algebra, our next unit, we'll use the distributive property and then we'll solve these, which gets super fun. All right, couple more examples. All right, got another one, 12r minus 9. So same thing. Gonna put 12 on the left. And then r minus 9. Again, they're doing subtraction or negative. Don't let it freak you out. We're just gonna, wherever that subtraction sign is, we're gonna draw our line. We're gonna do 12 times r, 12 r's. And then 12 times 9, what is that? 908, I think. Okay. And then, so my expanded form, I did 12 times r minus 12 times 9. And then for simplest form, I got 12r minus 108. And again, notice that sign just kind of followed us all the way through. Okay, no big deal there. All right. Use the distributive property to simplify the expression below. All right. So we don't have to write simplest form or expanded form. You're more than welcome to. We're just going to write the simplest form. So we're just going to solve this one. So let's do, here we'll do green. So we're going to 5 on the side, 3x plus 10. Draw my little rectangle. Wherever there's a sign, I'm going to draw a line. 5 times 3x is 15x. 5 times 10 is 50. So my simplest form would have been 15x plus 50. So this is what we want to get to. All right. All right, I did this one on purpose, and you'll notice if you have this on your sheet, it is not written this way. Most mathematicians would not write it this way, but whoever wrote your CFA for this unit did write it this way. And I do not think that is smart, but that's okay. So I wanted to give you a couple examples of it kind of written, I would consider the wrong way, but we can do this the exact same way. So what we're going to do is this 3 is on the outside, right? So I'm just going to take that 3, and it's going to be my outside number. And then the x plus 4 is going to go on top. Draw my rectangle where there's a plus sign. So notice all I did was I took that 3 and put it on this side. You know what? If you really wanted to, just not to confuse things, you could also put it over here. It doesn't really matter. You're going to do the same thing, right? I'm still going to do 3 times 4. I'm still going to do 3 times x. It does not matter which side you put it on. It's going to get you the exact same thing. So please, please, please don't let this order mess you up. It's the same thing. we're still distributing this 3 to the 4, and we're still distributing this 3 to the x. So I'm going to do 3 times x. I'm going to get 3x. I'm going to do 3 times 4. I'm going to get 12. So that my final simplest form would be 3x plus 12. So don't let them try to confuse you on some tests and try to mix numbers up, because no mathematician's going to write it this way. We're almost always going to put it on the left-hand side. But let's try one more just to make sure we understand it. All right, so notice on this one, again, I put the 12 on the right-hand side instead of the left-hand side. Don't let it confuse you. No big deal. So let's do 6 minus 2x. Do my little rectangle. And we could put that 12 on either side. I'm going to put it, I'm going to put it over here because that's where I would put it. If you want to put it on the other side, just to make it look like your expression up here, that's perfectly fine. So 12 times 6, what's that, 72, I think? And then 12 times 2x, I get 24x. And then I'm just going to write it in this order. So make sure you don't mix up your order here. So my final answer is going to be 72 minus 24x. So remember, it's okay for the variable portion or whatever to be next. You just want to keep the same order that they give you. So that's no big deal there. All right, well, hopefully this helps. We'll do more practice. This will be something that'll kind of roll over into our next unit too when we do some algebra. So this is something you're going to use probably for the next 3, 4, 5, 6 years. You'll use it in college. Like, this is super important skill. So if you don't understand, make sure you come see me. We'll do some extra practice. All right, thanks, guys.